This is lesson 3.3, multiplying and dividing rational expressions. So first, a rational expression is a ratio of two polynomial expressions. To simplify radical expressions, first we'll factor everything that can be factored, then we'll simplify the monomials using the exponent rules, and third we'll eliminate common binomial factors. So for this first example, we have 20x to the power of 6 over 14x to the power of 2. The first step is to factor everything, but there's nothing that can be factored here, so we'll go on to the second step and simplify the monomials. So let's break it apart so it's easier to see. This is the same. These two expressions are equivalent, and 20 over 14 can simplify to 10 over 7. And we know that this rule, a to the power of m over a to the power of n, is equal to a to the power of m minus n. So we can apply that to this part of the expression here. So x to the power of 6 minus 2 equals x to the power of 4 times x to the power of 4. And when we rewrite this, we'll put the x to the power of 4 on the numerator. And here's the final simplified answer. For the second example, the first step is to factor out everything that we can factor out, and we can take out a 6. So when we take out a 6 of this equation, we're left with k minus 6. Because remember, if we distribute the 6 to both, the k and the negative 6 will have 6k and negative 36. So now we have 6 times k minus 6 over the denominator, which is just going to move over as k minus 6. Now we can eliminate common binomial factors. So we can cancel out this k minus 6 and this k minus 6, so we just have our final answer of 6. So let's work through two more examples. So the first one, we have p squared minus 49 over 7 minus p. So we can see that this is a difference of squares. Which we know can simplify to p minus 7 times p plus 7. Then we're going to write this over 7 minus p, which is just this denominator. We're going to move it over here. Now there's a special rule for this type of situation where a minus b over b minus a equals negative 1. So when these two are the same and these two are the same, a equals negative 1. So here for this expression, we see that we have p minus 7 over 7 minus p. Which we can simplify to negative 1. So we'll cross this out and rewrite it. It's negative 1 times p plus 7. We'll distribute this negative 1 to the p and the 7, and we'll have negative p minus 7. For the second example, we're going to first factor out everything that we can. So common denominator of 12 and 3 is 3. Let's write the 3 on this side. And we have a to the power of 3 and a. So we can take out the lowest power, which is just a single a. And on the inside, we'll leave 4a squared minus 1 for the numerator. And on the denominator, 12 and 6, greatest common factor, or greatest common denominator, is 6. And a cubed and a squared is a squared. So we'll leave that on the outside of the parentheses. We have 6a squared, and on the inside, we have 2a plus 1. Now on the top here, we have a difference of squares. So we can rewrite this as 3a times 2a plus 1 times 2a minus 1. We'll rewrite it with our denominators on the bottom. And now we can cancel out any common binomials. So we have this one and this one, which are the same, so they're going to cancel out. So now we have 3a times 2a minus 1 over 6a squared. From here, we can simplify that 3 goes into 6 2 times, and a goes into a squared once, so we're just left with a. So now we have 2a minus 1 over 2a. If the problem contains monomials only, then we'll multiply everything together and then simplify. If it has binomials and trinomials, we'll factor everything we can first and then simplify. So in the first equation, these are all monomials because there's one term in each of these. So first we'll just multiply everything together. 6 times 10 is 60. X squared times x cubed is x to the power of 5. Y cubed times y to the power of 4 is y to the power of 7. Then on the denominator, 2 times 18 is 36. X squared is just x squared since we're not multiplying it by anything common. Y squared times y squared is y to the power of 4. Now we can simplify. So a common factor of 60 and 36 is 12. So we'll factor that out as 5 and 3. Now x squared goes into x5, x to the power of 5, 3 times, so now we have x cubed at the top. And y to the power of 4 goes into y to the power of 7 with 3 remainder. So we have y to the power of 3 up here. First, we'll factor everything out before simplifying. Focusing on this term, v to the lowest power is 1, and the greatest common denominator between 10 and 5 is 5. So we'll leave 5v to the power of 1 out here, and on the inside, we'll have 2 minus v. Multiplied by, then we're focused on this term here, and we can factor this out to v and find a term where added up they'll equal -8 and multiplied they'll equal -9. They'll have -9 and +1. Next, we'll go back to the other term and focus on its denominator. So on the denominator, we factor it out like this. What are two terms that will add up to -11 and multiply to +18? -9 and -2. And on the other denominator, we have a single monomial, so we'll leave it here as is. Now we can simplify and cross out any shared binomials. So v minus 9 and v minus 9 here will cancel out. 5 goes into 15 3 times, so I have 3 and 1. And here, if we remember the rule, a minus b over b minus a equals -1, we can change this whole term to -1. So now we're left with -1, this term, v plus 1 over 3. and we can factor in this negative 1, so we have negative v minus 1. To divide rational expressions, we can multiply by the reciprocal. So the reciprocal is just the flip version of what we're dividing by. So we have 5pq over 16p cubed multiplied. Now we'll take the reciprocal, so the numerator goes on the denominator. 35p squared times q squared, and 85, and 8q to the power of 5 on the numerator. So from the denominator to the numerator, and the numerator to the denominator. Now this is just multiplying two monomials, which we know how to do. So 5 times 8 is 40. P times nothing, because we don't have a common base there. We'll just move it down. Then q to the power of 1 times q to the power of 5. We get q to the power of 6 in our numerator. Then our denominator, we have 16 times 35, which is 560. P cubed times p squared is p to the power of 5. And we'll bring down this q to the power of 2. Now this number is quite large, but thankfully 40 goes into 560 14 times. So we'll cross this out. It's 14 times. P goes into p to the power of 5 once. So I have a 1, and this becomes a 4. Q to the power of 2 goes into q to the power of 6 equals 4. So now we'll rewrite this as q to the power of 4 over 14 times p to the power of 4. So now we're working with binomials. So now here's an example with binomials. So we're dividing by 4k plus 1. So we'll take the reciprocal of that. And remember that any fraction that's a whole number can also be simplified, can also be changed to that number over 1. So we'll multiply by this reciprocal. So we have k plus 3 over k multiplied by 1 over 4k plus 1. Then we'll multiply it by 16 k squared minus 1 over k plus 3. Then we can cancel out. Actually, before we cancel out, we'll have to factor this difference of squares here. The square root of 16 is 4. The square root of k squared is k. The square root of negative 1 is 1. So we'll set this up here. Plus and minus. Now we can cancel out like terms. So this k plus 3 and this k plus 3 cancel out. This 4k plus 1 and this 4k plus 1 cancel out. So now we're left with 1 times 4k minus 1 over k. And we know that 1 times anything is just itself. So to write it simply, we have 4k minus 1 over k.